Hello everyone and welcome to the EVN Disrupt podcast. My name is Artsakh. I'm the editor of the Creative Tech section here at EVN Report. My guest today was Marina Aghayan. Marina is the co-founder of AIP Tech and Fact Industries. AIP Tech is an Armenian company working on building 3D model devices for the medical and aerospace industries. We spoke about the success they've had over the last 2 years in building implanted devices for wounded soldiers and the work they're doing in building parts for the aerospace industry. Thank you for listening. Marina, thank you so much for joining us today.
Thank you for the invitation.
Marina, let's start with a little bit of your background. Tell us how you got started in the 3D printing world and the material sciences world.
Well, actually, my background is physical chemistry or chemical physics, as you know. And actually, for me, I consider that chemistry is a part of physics, just
Right.
a big direction of physics. So I started in Yerevan State University in a chemical department, my studies, and immediately I was involved in the research work. And when I was already 16 or like late 15, I already started my work in Institute of Chemical Physics. So later on, I had a chance to go to Spain and to do kind of a master's thesis, part of my master's thesis in Spain, and later continue some project-based research in Spain in the Institute of Ceramics and Glasses. That time, we were investigating like different projects at the same time. Actually, I understood and learned how to work with industry and how being a multidisciplinary researcher is very important, because we were doing at the same time biomaterials, studying properties and how to synthesize different biomaterials. At the same time, we were synthesizing different materials for automotive industry and aerospace industry. So like all is different, and we were working with industrial partners. It's very important for me to work with industrial partners because it's more strict, the deadlines are more strict, and you should work not only, you can create not only what you imagine, but also what consider the cost. And that gave me more industrial or business orientation in my life.
Right.
Later, we had a chance. Actually, I was invited to go to Estonia and establish a big laboratory because the institute, their university was making big investment in this area. We started to make very big laboratory, and we started to focus on 3D printing at that time. So the best way to learn about something is to create it. So because we had a task to concentrate on 3D printing, I started to learn how it can be used or connected to my background. It was about more than 10 years ago.
Oh, okay.
I think it was
so
12. Yeah, 2012. Yeah. It was just starting, and it was very risky also to take this direction because we didn't know what was going on and what will happen with this direction actually in the world, and how the market will grow. All this, like, we didn't know, like we were going with blind eye. And when we had already the printers, actually a lot of industrial partners came to us, and they had different problems, and we started to solve them. The first very interesting one was to make wheels for cars, sport cars. And
3D printed.
Yeah, 3D printed. Why 3D printed? Because in sport cars, they make these brake discs and so on, and also wheels, only like 20 pieces or less. And every time they change the design of the wheel or brake disc or like all these parts of the wheels, every time they change, they should buy new like molds, and all this costs like €500,000 or something, like all this project cost €500,000. In the case of 3D printing, you can change your design, and just print it, and if you need small amount of pieces, it's far cheaper to use 3D printing than other technology. So they turned to us to make such pieces for them, and it was like I think it was the first project that I was really interested in, and it opened my eye, and I understood how can we spread or distribute also our service and so on as a scientist, like to the industry.
Right, and commercialize that science.
Yeah. For me, like commercialization of your scientific background or your scientific knowledge or your scientific service is the most important and most fascinating thing that I do in the research.
Right, because you bring that science to the real world through some product or through some solution.
Yeah. And what I noticed, actually, all the students are more involved in the projects if it's applied research. So they like more. Yeah, they want their research or science or their work to come to the life in one point, and it's very exciting.
And then in Estonia, you did your PhD as well. There, right?
Yeah, I did my PhD, and at the same time I was working as a researcher. I had several projects simultaneously. Later, after this, I continued working after my PhD. I continued working in the university, also giving lectures and so on.
What exactly was your PhD in?
It was about nanomaterials. Actually, I was working in several projects simultaneously. My research topic, like PhD thesis, was totally different than what I was doing, actually. It was just a part of my job. It was about nanomaterials. We were making like different catalysts mostly catalysts or piezoelectric materials in order to save the energy or to create energy, using some nanofibers. It was also a very interesting job, actually. And at the same time, I was working this 3D printing stuff.
So before we get on to some of the things you're working on now, I want to ask a question about Estonia. So we often hear about Estonia as really this model for small countries who have been able to have really big breakthroughs in their tech sector. I think Estonia's tech sector reflects something like a quarter of their economy, if not a little bit more. Is there something Estonia does at maybe the grad school level or the general scientific ecosystem level that results in such successful commercialization of science? Is there anything they do there that you've observed that we can replicate in Armenia?
Actually, I think yes. Estonia is doing very smart country strategy, and everybody knows how the country will go, like where we should go, with all directions. For example, if we want to invest, or if we see our country within next 5 years in high tech, making the country high tech. So both and which direction of high tech, both scientific people from scientific direction or economy, all this will put their efforts to develop exactly these points, like where the country will go. So this is very important. For example, if we think that we are going to develop 3D printing stuff in this country, all the grants or projects or everything, and everybody in this area that works, both in science, in high-tech ministry, in economy, even in medicine, they should all support this direction. And
by direction, you mean narrow directions within that field, right?
Yeah.
Like, for instance, I don't know, in 3D printing, it could be maybe the country needs 3D printing for construction needs or for this very specific industry's needs. You mean those kinds of directions, right?
Because, like, for example, if we take 3D printing, I'm a specialist, I can talk about 3D printing much more, but also there are a lot of AI and other like smart stuff. If we think in 3D printing, you can touch every field. For example, in medicine, you can make customized implant. In aerospace, actually, a lot of parts are made by 3D printer now, In automotive industry, again, you can make parts like using this. Also, if you come to software and stuff, like there are a lot of softwares for 3D printing. So there are a lot, like wherever you go, you can use this 3D printing for this direction, And if you are putting all your, how to bring money to the country, when people or resident or specialist from other country know Armenia or this country as a 3D printing specialized country, if they have any problem, if they have any project, they come to you. For example, when you are applying for a project to collaborate with some space industry, usually like they look, if your country is successful in this direction, if in the country there are several, like at least small groups, working in this direction, they trust you to give this project.
Right. Right.
So it's the way how to bring money. If only one direction, if only this academy is investing money on 3D printing, but other direction they don't care, this direction, like early or late, will die.
Mm-hmm.
So I think that we should understand the strategy of the country, and all our efforts should go to this strategy.
Right. Another example in another space would be, for instance, in machine learning. There's a lot of agro-tech companies that build tech for the agriculture sector that use machine learning for increasing the productivity of that sector. And agriculture is a significant part of Armenia's economy. But a lot of agro-tech companies that work in Armenia still build solutions for the outside market, for the American markets or the European markets. So if there was some strategic direction across all these vectors, whether it be machine learning or 3D printing, that was more narrowly focused on Armenia's needs. You obviously need the startups that are focused on global solutions as well. But if some companies are solving Armenia's problems as well, that's how it would reflect in a much greater share of Armenia's economy and growth and stuff.
Yeah, actually, I think that we should not only focus on Armenian needs, but mostly global needs. For example, we can find solution like global solution for one company located in Spain, or that will bring enough money or much more money in order to just outsource the service that we need in Armenia.
I see.
So like all this, we should understand which is more profitable, where we can go considering our location, all this stuff, and our specialist, all this we should consider, and to understand like what we can buy and what we can sell.
Right.
Including knowledge, service, and everything.
So when we talk about strategic focuses in the 3D printing space, what are some areas that you think Armenia should be focusing on?
I think Armenia can focus on a lot of stuff. I am now, my group is now focused on medical, but mostly we are focused on aerospace industry, because the margins in aerospace industry is much higher. Mm-hmm. So when you develop one small piece, it can cost like hundreds of thousands of dollars.
Right.
So why not to sell this service to
large American companies that do aerospace or Boeing and stuff.
Yeah, and also I think medical can be very useful, because we have medical tourism regarding the dental tourism, but we can develop it. Armenia is small, so people can come and treat here and go, and it will be cheaper in Armenia if we can keep it cheap.
Right.
So we can develop this medical tourism in Armenia as well. Right. Why not to do?
So let's talk about AIP Tech. This is your organization that you started a few years ago. Tell us a little bit about the founding story and what you guys are trying to do.
Yeah, actually, the idea to open AIP Tech came from Nerush. Okay. The first time we just won a big project in Nerush, like it was $30,000.
Tell people what Nerush is for those who might not know.
Nerush, I don't know if we have this year or no.
I think they're starting it again.
That's good. It was maybe devoted to the diaspora or some interesting ideas in out of Armenia,
Right.
And the idea was to bring those ideas or those people to Armenia.
Right.
I don't know how many people come back after Nerush, but at least we came back.
Right.
And we got the first prize in advanced technology in Nerush.
Right.
And that was the start. Actually, we started the company. I didn't know how it would work. We came with blind eye, because I was living in Estonia and I didn't plan to come to Armenia at that time. It was just, okay, let's start and let's see how the team works. And at that time, the idea was to support Estonian company, which was, again, I co-founded one Estonian company. And the company had several contracts with European Space Agency also we do other contracts with different partners. And the idea was, okay, we will develop some tech group in Armenia and we'll see how they can support, and we can outsource some service from Fact Industries, Estonian company, to Armenia.
Right.
And it will be kind of the way how to earn money, the first stage, and later we can have, when we have one product, we can sell this. Yeah, we started this. Actually, the team, we trained a lot of people. We had problem with specialists and so on. This is a big problem in Armenia, the problem with specialists, and people also, they don't know how to work. Actually, sometimes they are losing their time. They don't understand the cost of the time. So they can sit and talk in the workplace several hours. So we had such a lot of problem. I was almost like disappointed. And in September, when the war starts, that time, like mentally, or a lot of things changed in my life, actually, in my mentality. I understood that, okay, if not now, if we don't go back to Armenia now, I mean, doesn't, like, in future, I mean, who cares, actually? You don't, I mean, you need your country when your country is in a bad situation. If you don't come that time to your country, so why you are coming later? So I mean, I don't see the meaning to come when my country is in a good position. So that time, I have decided that I should come back to Armenia. So there were a lot of people who had trauma. This is what also AIP Tech could do at that time. For example, if a part of the bone is missing because of the trauma or accident or something, we can repair it, actually. We prepare by 3D printer exactly this customized implant to put on this exact defect in order to save or to improve the life of the patient. And the first patient was, again, very emotional case, for us. The first patient was doctor who went to the war, again, to save other soldiers. And he had very big trauma in his leg. He continued working with such leg, like doing a surgery during the war. And when he came back, there was already like no way to save his leg, and they were going to, the other doctors were going to amputate it. And we suggested to prepare implant that could save his leg. Actually, we were quite successful in this, and later he came to say thanks to us. And this was the start also to take this medical direction for AIP.
Can you be a little bit more specific as to what exactly you guys printed and implanted into his leg?
Actually, how this process works, we get computer tomography of the bone, like 3D.
It's like a scan.
The scan of the bone. And later we see what is the defect, and later we discuss with the doctors how we could do surgery, because I mean, from engineering point of view, okay, you can prepare this piece and it will exactly fit to this place, but the doctors can say totally different thing. And we discuss with the doctors how it should work and so on, and later we prepare metal titanium-based piece in order to put this piece into the defected or into the place where we don't have bone. For example, I think for people it can be more understandable how we do with the head. For example, there is a big part of the bone in the head that dismiss. So from one side or from another side or from both sides, and we start to understand how this how we should prepare implant, kind of plate of implant that we put for this part of bone. There is also another example. For example, if we had a shotgun that the guy lost a very big part of his jaw, low jaw, and we also prepared like implant that we can put in this jaw, and kind of later we can, like, the guy can have also teeth there. So there are such a lot of over 30 cases that we have prepared.
These projects that you were doing, were they in collaboration with a specific hospital or medical institution? or were you working with just in general?
Actually, we are quite open to work with different clinics. The first cases we did only with Wigmore because we found out that only in Wigmore we could find that time surgeons who were experienced.
Right.
And we were also lucky that we had François Antonian, who was also co-founders of Wigmore Clinic. He had experience in US. He's a doctor working in US, and he came every second month after the war, only every second month to do surgeries here. So he supports and helps us a lot with his advices and so on. And after this, we started to collaborate with different clinics as well. We work very tightly with Erebuni Medical Center. But also we should go in advance and see the conditions that they work because we have also very bad experience. It happened that we went to the hospital or clinic, I don't want to specify, and we saw that actually they are not meeting the simple requirements, medical requirements, to do surgery. You can't do in this room surgery.
Right.
So, I mean, there is no condition, like the temperature is 40 degrees C and so on, and the window is open. Like, there are a lot of problems. And we have decided that we are not going to collaborate with such clinics where there are no professionals.
Right.
And we participate in every surgery, and we see that during the surgery, if there is any problem, like that professionally is not the level that we expect,
like your team members are in the operating room?
It's must for us.
Yeah. Do you guys have medical doctors on your team as well? Or?
We have 3 medical doctors actually who are all the time consulting. Every case, they should prove that this is okay to go for surgery. It happens that we change the model even 12 times.
Right.
So, because the doctor changed the strategy totally of the surgery, because we should understand from where they want to open.
Right.
What is the next stage? We had a patient that had huge problem with hip joint, and actually part of hip dismissed at all. And this was also the mistake of our doctors, in our doctors in Armenia. Right. And we know that the second stage is to do surgery of the next hip.
Right.
And we started as a puzzle to collect all this hip in order that he can walk after at least half year. But actually he walked earlier than we expected. But all this should be considered, and we can change the strategy several times.
Right.
So,
After the war, how many soldiers did you guys prepare 3D printed?
We did over 30 soldiers. And for now, we stopped the process, to be frank, because, financially, we came to a point that the AIP Tech couldn't support anymore. Financially, we were...
You guys weren't charging for it? Or,
because we were not charging from the soldiers. We started to collect donation, but it was unsuccessful. People say, okay, the country, Republic of Armenia should cover this cost. Why we should donate?
What are the costs like for something like this? I'm sure it ranges a lot based on what you're printing, but let's say, for instance, the hip joint procedures and stuff. What are the ranges like? Yeah,
hip joint is one of the most expensive one. It starts from... $3,000, not too simple. Actually, the simple one, we just say you go to use like the standard implants.
Right.
But if there's a problem, it starts from $3,000. But for the jaw or like maxillofacial or cranial implants, for cranial implants, it starts from $800. $700-800.
Right.
It depends, how big it is, how difficult is the process. We mostly calculate how much we work on this and how much the doctors work on this.
Right. And is that just the cost of the materials, or is that the labor of the team and all, like end-to-end costs, or just the materials?
It's the cost, is the price of the implant, Armenian price.
Got it.
Because we have different cost strategy for different countries.
Right.
In Armenia, we understand that we can't have
that's understandable.
Too much profit. Again, we are working almost without profit.
Right. Right. And do you guys prepare medical implants for the outside global markets as well? Europe?
Yeah, we export a lot. There we have totally different price strategy.
Right.
Actually, in Armenia, we don't work for profit.
Got it.
This is the price without profit.
Right. It's something you're doing for the country.
Yeah.
Have you guys raised any capital other than the Negros grants, or?
We had also SASTIC.
Okay.
We had $30,000 from SASTIC.
Yeah.
So, but later we stopped raising money because everything is going more steadily than we were expecting. And for now, we don't need investment.
Okay.
Actually, we have developed new product that is biodegradable, like biodegradable implants. And in this case, instead of titanium or PIC implant that we put into the bone and it remains in whole life, we will have new implants that will degrade during the time and the new natural bone will grow.
Wow.
So this is ready. This we already put on humans, and I think soon it comes to the market. Mm-hmm. Actually, we are planning to sell it already in the end of this year, but there are documentation that we should finalize, legal aspect and so on.
Do you guys patent these?
Yeah, we have applied for patent. We are waiting for the result, actually. AIP now has already 2 applied patent for now, within 2 years. Mm-hmm. And
these are US patents?
No, they are European patent.
Okay.
And we are going to apply for one more soon, maybe in one month.
Yeah.
We have also in Armenia problem with patenting stuff, so this is another story that we can talk maybe. So
have you guys tried patenting stuff in Armenia?
In Armenia it's I would say not possible or possible, and there is no meaning to go for this, because when you take the idea, how they work, you should make all this stuff written and print it, and you are taking all this stuff to the to an office
patent
or not office. There is a box that you just put all this in the box, and it is in the corridor, in this building.
Oh my God.
So somebody can just come, take this box and go.
Wow.
I mean, there is no NDA. There is nothing. I mean, somebody can just take it, copy, and submit another patent.
You're better off not patenting it.
Yeah, I mean, we went there. Later, we decided not to do it. But the problem, you can't apply from Armenia to European patent if you don't have
a local patent.
Oh my God. If you didn't apply for a local one.
Oh, wow.
So that's why we apply for patent with our partners.
Okay.
It's crazy, but I hope and I'm sure this will also be regulated somehow very soon.
I hope so.
Because this question, with this problem, we went to corresponding people.
Right. Yeah, I never heard of what patent procedures are like in Armenia.
I don't know how others are doing in Armenia, but this was the experience that we had.
Right.
It wasn't good. So maybe in the end of this year already, when we have sales, the first small sales in Armenia, we will look for bigger investment. Yeah. In order to make a factory already.
A factory? Uh-huh.
Yeah, or big manufacturing line. Because as far as we even didn't start to sell it, but there are a lot of doctors actually we have from Estonia, Finland, we have from Russia that they were very interested.
Wow.
We have from Georgia, and they write us very frequently when it's ready, we are ready to buy it, we want to buy.
So there's a big demand for it.
There's huge, yeah. I mean, they are coming. We didn't do any advertisement. They are just coming.
Yeah. So I'm curious, what does a 3D printing manufacturing line look like? Is it just a bunch of 3D printers that are running simultaneously, or? No,
you can have one printer, but it still costs on you. I mean, the cost here is not so much the printer, but the condition to. I mean, it depends. First of all, it depends where you are going and for which industry you are serving. For example, in the case of medical, you should have clean laboratory.
Right.
Here you should have you should prove that the air is clean, like everything is clean when stuff
the
is
maintenance
entering
of
there.
the environment is super important.
This is far more expensive than the 3D printers actually.
Right.
So and all this documentation, if you want to get certification, ISO or CE mark and so on, all this costs a lot.
Right.
So this is and you can't put your printer in wherever building you want.
Right.
So you should have all this necessary, let's say, also communal or all this stuff. Adapted to this industry.
Mm-hmm.
This is for medical. For if you want to produce something for electronic industry, really, in some cases, again, it depends like which exact part you want to produce. In a lot of cases, you again need this clean laboratory.
Right.
So when you enter to the laboratory, also you should be totally covered and you should pass through air shower and so on in order to...
Oh, wow.
Actually, for electronic industry, that I have also friends who work in very huge companies. They are decision makers, and when they create new laboratory for new production line, they also have very clean room, and they need also air shower as we need for medical. They need also air shower to enter to this room. Like before you enter with specific or specialized clothes, uniform, and like air is coming, cleaning you, and you should make sure that there is no dust entering to this place.
Right.
So.
Other than medical use cases that you guys prepare 3D printed parts for, you said you also do stuff for the aerospace industry, right? Here in Armenia?
Here in Armenia, yeah.
Right.
Yeah.
Can you speak a little bit about what types of parts are 3D printed for aerospace use cases?
Actually, now we are making service for this. The idea is, actually, our Estonian company has several contracts with European Space Agency.
Right.
One of them is about to make electronic packages for microscope. And also it will be used for telescope as well. So there are special devices for this. And the idea is when it works, for example, telescope works in space, there's a huge temperature difference. Yeah. And there are vibration and so on. And the idea is to prepare these packages from new materials, which will not expand, or they should expand with the size as the screw in this small piece are expanding.
Right.
So the material should be more or less close, or they should have more or less close properties.
Right.
Plus, they were looking for the material which will have high thermal conductivity. It means when the device it gets hot, like the thermal energy, like the heat should eliminate very fast. So this a very big part of this project is done in Armenia, actually, by AIP Tech, because here, first of all, in Armenia we have devices actually, and this, for characterizing, analyzing, and so on, and it costs much cheaper than in other countries. So we have everything under hand, and we can go to do microstructural analysis or XRD and so on, and it will cost like very
cheap
low,
compared to
other countries. So, and we took this, and the team is I'm proud that the team can manage with this project. Also, the result is satisfying for space industry, space agency, and now they are interested to make another contract.
Nice.
The problem why AIP can't directly work with European Space Agency, although they know that they give to fact industries, and fact industries is outsourcing to AIP. Yeah, the problem is Armenia itself should enter to European space industry. Only in this case they can give us project. But this is another question. I mean, does it make sense for Armenia to enter to European Space Agency to be registered? Because for being a member of European Space Agency, you should pay for this. And this is the cost is very high. So like we should think and understand, does it make sense? Can we bring all this money back to Armenia
Right.
if we invest this money in European Space Agency, or we can try still like to work through other companies with European Space Agency. So all these are questions I think we should think, the government should think, and they know better, like how much money we can bring back, because they know better which kind of companies we have in Armenia that can collaborate and bring money.
Is the reason why the European Space Agency won't work with non-registered countries because space tech is often used in military applications and things of that nature as well, or
they are not members, and you should apply for being member, and this application is also you need a lot of documentation, you need a lot of requirements and so on. I think Armenia basically can prepare and enter there, because right now we have enough scientists, we have enough specialists in this direction. Also, diaspora is here with us, and we have enough network to take and carry out all these projects.
Right.
But we should still calculate. I don't know. This is the government should do. I can't just advise that we should enter. I mean,
tell us a little bit about AIP's team. How big are you guys now?
Now we are 11 people there, but we are going to increase actually. We plan to increase to 15 by the end of this year. We will see how it will go. And
is your team comprised mostly of 3D printing engineers, or is it much more diverse than that?
Yeah, actually it's much more diverse, because the work of manager, for example, project manager, sometimes it's more important than sometimes you get case like the doctor comes with computer tomography and you should manage where it should go later. So if you don't plan it and you don't push the specialist to work, you have big problems. No, it's not only 3D printing specialist. We have project management, 2 people. Yeah, we have modelers and specialist engineers who are working on 3D printing.
And then some domain experts like doctors and stuff, right?
Yeah, and we have doctors, 3 doctors actually working there.
Let's talk a little bit more generally about the prospects of 3D printing. One thing I often see in the news is 3D printing of organs and things of that nature. Is 3D printing in the medical field globally already highly adopted? Is it used pretty much across the board, or are we still in the very, very early days of seeing this stuff be adopted? And are some of the things that we read about, like 3D printing organs and stuff, is all of that just hype so far, or do we know how to do it and we'll see how it'll become implemented in the coming 5 years, 10 years?
Okay. Actually, 3D printing of organs, till now I have seen in the research only.
Yeah, it's just...
I have... Well, I read that there is already cases that they change. But how it will work, we will know in 5 years. Because, for example, even for us, that implants for bone, heart tissue, is already known for 15, 20 years.
But it's just being brought to market?
We just... they start selling only after 5 years. Even like when we prepare, we don't, we keep this case in our, we follow the case for 5 years because you never know what will happen in 5 years. So all this is a big question, but I believe in it, that I believe that soon we will have 3D printed organs, and it's not a fantasy. Actually, there is also very buffering situation in the documentation. For example, Europe needs for each device or each, let's say, well, in professional language is device, also the implant is device. So each device that comes to the market, or if you sell any piece, you should have CE mark. CE mark means like that all, for example, if you produce the glass, you say that, okay, it's 5 centimeter to 5 centimeter and so on, and you have accuracy of 0.1 millimeter. It should be, all your pieces should be like that. So it's kind of regulation of quality.
Got it.
Of the pieces. The same we have for 3D printed stuff. The question is, okay, if every time we have totally different implants, because it's customized, every person is different. So every time you prepare totally different implant, how you can make CE mark? how I can compare one product with other products. You can get CE, for example, in CE mark, you should have 20 pieces and they should take one out of this 20 pieces and see if it fits the description that you gave to him. For example, if I describe that the hardness is like this, the microstructure is like this, the surface roughness is like this, etc.
Right.
I mean, if I prepare from each implant 20 pieces, it will cost on me not 20 times, but at least 15 times higher.
Right.
So it's not affordable anymore. I mean, here there is such kind of problems. Some countries started to have to adapt, to 3D printing market. For example, in Emirates, they have their CE mark kind of like regulation. Whenever your product enters to Emirate, they do just based on your description. They check only this implant, and it goes to the clinic, and it takes 4 or 5 hours. In Europe, they don't understand yet how they should do this. So that's why market is, you can still enter to the market. As soon as they make this strict regulation, the cost will be increased.
Got it.
The UK, I guess UK is working on this now because we have partners in UK that are interested to buy, and they want also that our product should pass also through this regulation, but I am not very sure how it will go.
When it'll be,
the market is increasing very, very fast. Actually, CAGR is over 20. It's very high.
Yeah.
So it means that still companies who want to enter to this market, still they have chance to...
Right. It's still emerging. Yeah. Marina, let's speak a little bit about what's needed to increase the number of 3D printing specialists in Armenia and what directions they should come from. Can you tell us a little bit about how in much more developed ecosystems, what education paths or career paths typically someone that is involved in 3D modeling takes?
When we are looking for staff, we are looking for specialists who knows what is material science and who knows about who has deep knowledge in chemistry, physics, general material science. For us, it's easier to teach the material specialist, material scientist, 3D printing stuff than vice versa. Because when we announce some job vacancy and so on, people who can just use 3D printer, like this filament-based 3D printer, they come and apply, but we see that they only know how just to buy from the market filament, put into the printer and start to print something.
Right.
Actually, this is a very, very small part in the market, like filament-based 3D printing stuff.
It's not that
they
simple.
can do at home, like play or to make some toys out of this. It's a good tool for children to understand 3D etc. In general, 3D stuff, and learn how to model. But this is very, very, very small part in the job.
Right.
In our company, we have only one 3D modeler, and the second one we are hiring now. But mostly people are material scientists who can prepare new materials for 3D printers. For example, powders, polymer-based slurries that you can use in order to make ceramic pieces.
Yeah.
Powder also, they can be ceramic or metal-based, and you should understand how the powder should look like.
Yeah.
It should be spherical or non-spherical, or it should be big or small, or it should be combination of different materials in order to be able to print. Which kind of laser you should use, power of laser, speed, etc. All this influence on the quality of the final part.
Right.
And all this, the person should be ready to understand and should understand. It's not easy.
Right.
Yeah. And all this, I think it should come from the school. And actually now we are working also with universities in order to teach young specialists material science. We start from material science. Also how to prepare new materials for 3D printing. because selling material for 3D printing is more like profit is much higher.
Right.
The market is bigger and so on. For service, I mean, you can do, every day one specialist can do like 10 modeling, not more.
Yeah.
But for powder, you can produce tons.
Do we have material science graduate programs in our universities in Armenia?
Now we have material science master program in Yerevan State University. This year we had only 4 people who applied, and I mean, it's free, you know.
Right.
There's scholarship on this, and there are 15 free places, and only 4 people applied.
So we need to do a better job of telling people about this.
I mean, I think we should start from the school, even not from university. Now we work with universities to teach like specialists or young specialists and students that, this is also a profitable job.
Right.
But if you are looking only for profit, I mean, it's not the place.
Right. It's faster and easier to get somewhere else.
Here we need people who have knowledge, who have interest in science and so on, and to have readiness to learn and learn and learn. But I think we should start also from schools, especially going to different towns or villages and talk to students, high school students.
About the potential.
Of this direction, and like at least to give 1-2 lecture in even small schools, because what we have noticed that all talents come from small countries. I don't know how it's small towns and so on.
Right.
I don't know why it's like that, but actually maybe they don't watch TV so much, or they are not in their gadgets so much, and they have time to create and create like anything from the mood or like they are more curious. And I think we should start this program also maybe from Gyumri, but we are thinking about it as well.
And material science is a very diverse field. It's not just 3D printing. I think battery production, a lot of things in electrical engineering and stuff require material science background as well.
Yeah, it's huge. It includes physics, chemistry, everything, and you should be very multidisciplinary. And for example, when I give lectures, I give like one task to everybody that they should like homework they should prepare at home. Like just take any part or any small piece that you like even glass, or take a piece from the bicycle that you have at home, and learn you want to change the part, which kind of materials you are going to take. Right. Bicycle is composed of over 100 pieces, and each piece has different material. Right. Just take one and tell me about the material, why engineers chose those materials. Right. One student didn't like my subject too much, and once he came, I said, okay, I'm going to take a glass. And these paper glasses for coffee. And the next day came, it's very hard. I say, of course. He said I should think about the polymer that you use inside, what should be the thermal conductivity of this in order that you don't burn your hand. Right. So all this I should think. And later he said, okay, I'm going to be material scientist. It's quite interesting. Every time you look around, you should think, what is material, why it's made of this, and so on.
How it's made, and
it's very interesting, and there are a lot of job on this, I don't know.
Yeah. So last year there was a great story about a group of young people in Tavush that started Protolab, I believe it's called, a 3D printing company in Noyembergen, I believe. Yeah. And recently they did this 2-day conference in Noyembergen where they brought in people from all over Armenia to talk about 3D printing and some of the stuff that they've accomplished there recently. And they crowdfunded the whole company, I believe. And you were one of the lecturers there. It's just such a great story about young people, especially outside of Yerevan, doing something awesome for their community. Can you tell us a little bit about how those 2 days went and what the activity is like there?
Actually, it was amazing event, and it was amazingly organized. I was surprised how teenagers can organize such big
for people
conference.
Who don't know, they're 16-year-old kids, I think.
And there were schoolboys, schoolgirls, and there was no even small thing that could disappoint you. Right. Everything was perfect. I didn't know how how they could do this. Actually, the idea is for me. The idea why I went there and made a lecture to spread this 3D printing or high tech stuff more to people who are out of Yerevan or it's important to tell new generation that there is other, like there are directions, like technical, not only IT, also hardware, productions and hardware service, and also there's science that you can work there, you can earn money. Because a lot of people in Armenia think that if you are scientist, you are poor. It's not like that.
Right.
Already, like good scientists get similar salary as IT guy. So I mean, this is something that we should tell people, especially young like school girls or boys who are just thinking about their career. It was amazing. Later we had a camp. We sit around fire. A lot of people could talk, discuss, and so on. They were singing, dancing. Everything was amazing, actually. And actually, it's very good that we have Protolab for several reasons. One of is that a lot of other teenagers can know about this and can be encouraged to create or start their startup. I don't know how long this startup can exist, because usually when teenagers start a startup, later
they go to university or something.
And later this startup will, I don't want to be pessimist, but it's a good example for all of us that they can and they will do. And I hope very much that they will continue on this.
Absolutely, And regardless of what happens, it's a phenomenal experience to gain at that age, and so it's huge experience. Like they will. I taught them which kind of problems they will have in near future if they don't have till now. Soon they will have problem with money. And like a lot of people, we start to look for other source of money because they used already to money, you know. When you have money and later you don't have, you should start to live with $1 per day or something like that. Otherwise, you are closing your startup. So, all this, they will have all these problems. Are you involved in Protolab at all as an advisor or something like that? Just a friend?
Just a friend, let's say. And now with Argham, we are like the co-founder of Protolab. We are in connection. So I am ready to help, to support, but I don't want to support so much that they face with problems.
They have to be independent.
This is experience. They should face with this problem, because only problems can make you stronger. I have co-founded 2 startups. In 2 cases, I had the same problems that I told them.
You have to go through it.
Sure. You should learn, first of all. For me, it's the biggest school. You should learn to have no money. And to discuss with huge partners to sell service with 0 drums in your pocket. So if you have this mental stability and you have emotional stability, so you will success in life.
Right. That's a great advice.
So for me, well, also there are a lot of other problems. For me, this is the biggest what I found out, that people will face problem, and later, like, collecting team is the hardest stuff. You can't be in the same board with different people who think in a totally different ways, and you should all the time fight for your rights. You should fight for your ideas, for your strategy, and you should accept others' ideas and strategy. It's not easy. Just if we say, like, it looks easy, but it's not.
Yeah, for sure. Marina, let's talk a little bit about the future now. Where do you hope to see AIP Tech in the next 5 to 10 years? What problems do you hope you'll be solving then?
Actually, we have our strategy. We will be feedstock manufacturer, actually.
Sorry, what manufacturer?
I mean, we are not going to give like 3D printing service, just to 3D print, but we will be group who is producing new materials for 3D printers.
Okay.
So I'm sure we will be quite big company. in near 5 years at least. Not only in medical direction, but mostly focus on aerospace direction. And I think that this will bring enough impact to Armenia in order that in Armenia we have not only AIP in this direction, but also several companies that can rise and they can understand that it's possible to go to this market and to be big, let's say.
And how can people reach out to you if they're interested in collaborating in some way, or maybe they're interested in purchasing from AIP? Tell people how they can find you.
Actually, they can Google they can enter to our webpage, AIP Scientific from Science by AIPSCI.com.
Okay.
Or they can find us also on Facebook. They can write there and very fast they will get reply.
Yeah.
I don't give phone number because once I gave phone number and people were calling like 11 p.m. or 12 p.m. and they say I have problem with my bones, come to repair it. I said okay. So, it was funny, but yeah.
Right.
So
the website's the best way.
Website is the best. Yeah.
Okay.
They can find us there.
Marina, thank you so much. Usually when I have a guest on, I know at least a little bit about what their field is like and what they're doing. Today, I can say I honestly knew almost nothing, and it was super educational for me. So thank you so much for being here, and I wish you a lot of luck with AIP Tech.
Thank you, Nishta.
Thank you, Marina.